Hi, Colin Lennox here, CEO of EcoIslands LLC and Permacycler, also of BioMining Products. Just recently this year, the first hemp crop in a really long time was grown in Pennsylvania. And I hooked up with those wonderful people and got some hemp for my bioreactors. These are for acid mine drainage. I am here at MB Energy's Dietrichs site. They've been a client of ours for a couple years. And we build bioreactors that pull iron and aluminum. What you see right here is a big manganese bed. These boxes then were specifically put in to pull the iron and aluminum as much as possible before it gets into their manganese bed. Alkalinity cell, that's limestone. And what we did then was throw in a bunch of hemp to even out some spaces where we needed a little bit more material, some more surface area for the biofilm to grow on. And biofilm is self-selective, so it's determined by the water going through the tank. Now the hemp here is going to break down a lot faster and act as a food source for fungi. And fungi, also the white rot that was in this partially composted material, are known to oxidize manganese from solution. But you got to get all the iron out first. That's one of the findings that we'd had years ago. So pull all your iron, pull all your aluminum, and then your manganese bed is that much more effective. Near as we can tell, this is the first use of hemp anywhere in a self-selecting bioreactor. If this were the permacycler embodiment and these things were inside of a greenhouse or a grow space of any kind, the hemp then would be the chopped up stalks of your leftover medical marijuana. And in this way, because the boxes are gassing off into the greenhouse, you're getting your carbon dioxide and your nutrients back. Now you'd have a recirculation pump on a system like that instead of it just going straight through. This is a gravity flow system. It's running probably 15-20 gallons a minute. Most efficient rate for these tanks these permacyclers are actually about 60 to 75 gallons a minute. So they are running slower than they should. It does reduce retention time, but it increases the overall load removal, which can be measured on the efficiency of a lot of ways. Material broken down and consumed and how much you got to put back in, or influent and effluent of the water load. If it's mining, how much metals did it pull out? If it's agriculture, what is the phosphorus and the potassium, as well as maybe some sodium, magnesium, manganese, iron, your micronutrients. So this is in essence then also your nutrient water. And they also work great as aquaponic tanks. You just wouldn't put as much material in, and then critters eat the material. I've got a crayfish in one of my tanks that goes to town on pretty much anything you throw at it. So aquaculture, aquaponics as well. I've got a fully aerobic tank here that you can do a lot with. But yeah, hemp. Use it in your bioreactors. This is Colin Lennox, signing off.